Consider the table of values below. So these are just standard angles that we know. We know sine of pi by 6 is a half, for example. Using your knowledge of the exact values and the unit circle, complete the table below. So if we think about the different regions, so here we're going to be in this quadrant, and we know that the sign is positive in this quadrant. So if we think about 2 pi by 3, which is just here, the associated acute angle is pi by 3. So the sine of 2 pi by 3 is equal to the sine of pi by 3. So that one is root 3 over 2. Then if we think about the 3 pi by 4, so that's going to be here. So this angle is 3 pi by 4. The acute angle here is pi by 4. So that's just equal to the sine of pi by 4. So root 2 over 2. And 5 pi by 6, if we think about that one. So 5 pi by 6 is just here. The acute angle here is pi by 6. So that one's going to be half. And then sine of pi, well, if we think about pi, so that's going to be here. And the coordinates of this point on the unit circle are -1 and 0. The sine is always the y coordinate, so sine of pi is 0. So we're now moving into the third quadrant. So we know that's the t quadrant, so the signs are going to be negative here. 7 pi by 6 is here, so that the acute angle is pi by 6. So this one is going to be -1/2 because it's in the t quadrant. Now this one here is here, 5 pi by 4. The acute angle here is pi by 4. So it's going to be negative root 2 over 2. And of course the negative because we're in the t quadrant. Same sort of thing here, 4 pi by 3 is down here. The acute angle is pi by 3. So that one's negative root 3 over 2. And then if we think about 3 pi by 2, that's down here, the coordinates of this point on the unit circle, 0, -1. The sine is always the y coordinate, so this would be -1. Then moving into the fourth quadrant, which we know of course is the c quadrant, so the sine is negative here. 5 pi by 3 is down here, the acute angle is pi by 3, and so that's going to be negative root 3 over 2. For 7 pi by 4, that's here, the associated acute angle is pi by 4, so that's negative root 2 over 2. 11 pi by 6 is here with the associated acute angle pi by 6, so that one's going to be -1/2. And then 2 pi is back to the beginning, so that's going to be 0. So we now want to plot y equals sine x for the domain 0 to 2 pi. So we might want to get decimal approximations for some of these surds so that we can plot them. So if we think about, let's go to decimal here, and let's have root 2 divided by 2. So that's about 0.7. We're not going to be able to plot any more accurately than that, so we can say that that one is 0.7. And then what about root 3 over 2? So root 3 over 2 is about 0.9. And of course half is 0.5, so that should enable us to plot. So 0, 0. So pi by 6 is here, so that's going to be at 1/2. And then pi by 4 is between pi by 6 and pi by 3, and that's going to be 0.7 there, so that's going to be there. At pi by 3 we're going to get 0.9, and then at pi by 2, which is this one here, we're going to have 1. And then we can see that they're coming down again, so is going to be 0.9, and then halfway in this gap is going to be 0.7, then 0.5, then pi, and so this one's going to be negative 0.5, and then in the gap here we're going to have negative 0.7, just here, and then we'll have negative 0.9, then negative 1, coming back up, we've got here, 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 and finally here. And so what we need to do is try and put a curve through this. So not that easy to do on the screen I'm using, but I think that's quite reasonable. And so we can see this is one complete oscillation of the sine curve, and we'll talk about that in a slightly later lesson. We're now asked, what is the range of sine x? Well, we can see, looking at the y-axis, that the curve is always between 1 and negative 1. There's nothing above or below. So we can say that y is real, y is between negative 1 and 1. Or we could write sine x here instead of y.